So this is the solution video for problem set 6, problem 3a. In this video, I will only be solving A and C, I guess. I won't be doing B and D because I feel they're somewhat redundant, and you don't really want to see me solve the same problem 4 times. So you can look at the PDF to see exactly how I did it, but I just want to show you the procedure here. So as I mentioned in class, the first thing you want to do is start with where you want to go, as well as what you're given. So I know I want to make a T flip-flop. That's what the problem tells me. It tells me to build one. And so I'm going to have T, Q, and Q bar, which I need to solve for. And I have a clock on the inside. And I'm going to need to build that with a D flip-flop, Q, Q bar, and a clock. That's my D flip-flop. And I know right away that I can hook my clock up to my clock, my Q up to my Q bar up to my Q bar, because that's just going to make my life easier. So the next thing I need to figure out is kind of how I'm going to get there. So I need to figure out the functionality of a T. So I've got T and Q. That's my inputs, and I'm going to have Q plus for my next state. And then I'm going to need to solve for D using my excitation tables. So T is 0, and since we have 3, so actually no, sorry. We're going to have 0, 0, 0, 1, 1, 0, 1, 1. We only need these down here. So when T is 0, Q is 0, we're going to hold Q. So it's going to make this Q 0. T is 0. Q is 1. We're just going to hold again. When T is 1, we're going to toggle Q. And then we're going to toggle this one as well. And so that makes D 0, 1, 1, 0. And so D is equal to T Q bar, or T bar Q, which is equal to T XOR Q. So I put my XOR gate here, and Q, put my T into here. And that completes my circuit. And now for a slightly harder one, I will do part C, which is not one I've done in a lecture. So for C, we want to build a JK using only a D. So start the exact same way as I've always. Show where I'm going. So I've got J, K, so I want to build Q, Q bar, the clock, and again I'm going to put my D flip-flop in. Q, Q bar. So I've got all that connected, and now I just need to figure out how, with these JKs, how my next state and excitation tables are related. So I'm going to have J, K, and Q as my inputs, so 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. And then I need to figure out my next state, and then I will use excitation table to do this. So as JK is 0, that's a hold, so Q is plus is going to equal Q. This is a hold again, so this will be 1. 0, 1 is a reset, so these two will be zeros. These two are sets, so I will make these both 1s. And then 1, 1 is toggle, so this 0 will change to a 1, this 1 will change to a 0. And for my excitation table, D, Q plus. D is just equal to Q plus, so I just do this exactly. Now I have a couple options. I could try to do this in my head, which doesn't seem too appealing, or I could just do my K-map. So I will put Q here, JK up here, and my D. So 0, 0, 0 is 0, 0, 0, 1 is 1, so this is 0, 0, 1, 1, 1, 0. So we've got that loop, that loop, that loop. So I only need 2 of these. This is essential. This is essential. So D equals J bar K, or Q, so that's K bar. And so I'll need that, and I will need both K and K bar, so J and K into an AND gate, K bar and Q, into an AND gate, and these into an OR gate into D. And that completes part C and this video.